I come back to your homes through a lovely Zhyar channel, and for today I'm going to mention the next type or the second type of the reaction in a chapter 1, which is ionization. Okay? In a prior lectures many times I mentioned that we have two types of reactions in this chapter that are related to ionic compounds and molecular compounds. For the ionic compounds we have the dissociation that we talked about in detail, okay, and we spent almost 3 lectures. For today we have ionization, the second type of reaction. Surely ionization, that means we must have, okay, let's see, we must have polar, okay, we must have polar molecular electrolyte. Polar molecular electrolyte compounds. So ionization occurs in a molecular compounds. When I say molecular, I mean it's electrolyte, okay, please. Because we are working with electrolyte right now. So for me, it's sometimes it will be difficult all the times to say polar molecular electrolyte. No, I just say molecular compounds. When I say molecular compounds, through the ionization process, I mean the electrolyte, okay? Because we knew that non-electrolytes are, they don't go through ionization. They just become a soluble molecule, okay? Ionization, one of the most important parts of this definition is forming ions by the action of solvent. Forming ions by the action of the solvent. It means without solvent, no ion can produce. Okay, we will get some ions that they were not present previously, and they will produce. They will be formed by the action of the solvent. What type of compound can undergo the ionization? Molecular compound, which is electrolyte. Okay, very good. And now, we have a question. What is the responsible factor behind the ionization process? Or what makes something ionize in water and something doesn't? Why some molecular compound can ionize in water, but some of them cannot? Why? Okay? For answering this question, we have to mention the attraction force within a solute molecule. Let's see. Suppose that we have HCl. If we include HCl in a jar filled with water, the molecule of HCl will be surrounded by water molecule, just like this. From everywhere, it will be surrounded by water molecule. And there will be 2 attraction forces. The first one, attraction force between the atoms of the electrolyte, which is H and Cl. So, I mean H and Cl. This attraction force plays a major role of its ability to undergo through ionization. Okay? As much as this attraction force gets weaker, it will be more ionizable compound. And as much as it gets stronger, which is hard to break down, it will be so hard to producing ions, so it will be the ability of going through ionization will be decreased. So the first attraction force is attraction force between solute particles, or the attraction force with the solute molecules. And the next attraction force, which is between solvent and solute. It's solute. And it's solvent. Okay? If this attraction force is stronger than this, it will be ionized. It will ionize. It will be ionized. But if this attraction force is stronger than this, it won't ionize. So, okay, I just put letter A and B here. If A is bigger than B, there will be no ionization. But if B is stronger than A, it will ionize because of water can break, can split the bond between H and Cl so easily. Because of the attraction of water will overcome the attraction force between the hydrogen and chloride, so they become free, okay? And we will say, it ionizes. Very good. And now let's get back to the main page. The extent to which a solute ionizes in a solution depends on the extent and the degree of the ionization depends on what? Did you remember? There was two attraction forces. Just now I mentioned it. So the degree of ionization depends on both attraction forces that I showed you just now. Okay. The strength of the bond within a molecule. Did you remember? The strength between H and Cl, the first one. The next, the strength of the attraction, between the solute and solvent, water and HCl. So it means this. When does ionization occur? Did you remember? If the attraction force of solvent is stronger than the attraction force within a molecule of solute. And now it's a general question and it has a general answer. Why this compound ionizes in water? Well, you can say, why it ionizes in water? Because of water attraction force is greater than the attraction force within a molecule. Why it doesn't ionize in water? Because of the attraction force within a molecule is stronger than the attraction force of water, or solvent and solute attraction force. Very good. Why HCl ionizes in water? That means water attraction force can overcome the attraction force between hydrogen and chloride anion. Because the attraction force between solvent and solute is stronger than the attraction force between solute molecules. It's very easy. The difference between the dissociation and the ionization. The dissociation and the ionization, we have talked about both of them in detail. Dissociation related to the ionic compound, but ionization, polar molecular electrolyte compound, okay, it's by the action of solvent, without the action of solvent. Question. A molecular compound can be ionized. Which of the following, it's firstly, must be a molecular compound? Okay, sorry. Okay. Which of the following is a molecular compound, firstly? So it must be a molecular compound. NaCl, it's salt. No, it's ionic. Yeah, it's molecular compound. It's molecular compound. It contains covalent bond and it's molecular compound. It's not a compound, okay? But it's a molecule. Very good. It's diatomic molecule. And it's a compound. Well, next filter can be ionized. It doesn't HCl. That means molecular compound that can ionize, we have to look for acids and weak base. Acids or weak base. Here we have acid. Okay. Which of the following presents in a molecular compound? A molecular compound contains polar and nonpolar. Very good. Only nonpolar covalent bond? No. Only polar covalent bond? No. Polar and nonpolar covalent bond? Yeah, it's a right answer. B. Good. Water attraction force, it's a wonderful question. Water attraction force is greater than the attraction force between molecules in. That means water attraction force can overcome the attraction force between molecules. Did you remember? What type of compound, the attraction force in what type of compounds can be overcome by attraction force of water, or can be breakdown? by the attraction force of water. Surely, because of it mentioned molecule, that means we have to look for a molecular compound that can ionize. Electrolytes, okay? Molecular electrolytes. The right answer. And now we have the next thing, which is hydrated proton. What is hydrated proton? Well, I'll open a white page and then I'm going to mention many important points. What is hydrated proton? Firstly, we have to talk about the proton. What's proton? Did I mean that particles, that elementary particle that locates inside of the atom in a nucleus section, or another thing? Proton here is different. Let's take a look with a hydrogen atom. We have hydrogen atom contains, in terms of protium, protium isotope of protium isotope, it's protium, okay? It's protium. Protium contains 1 electron and 1 proton. There's no neutron. No neutron, okay? No neutron. And now, when it becomes H plus, that means after losing its electron, so there will be only 1 proton. That's why H plus called proton. So please be aware, when I say proton from now on, I mean H plus, okay? And it has some behavior. It's super active. It can't stay freely. It can't. It cannot. It won't be freely. Immediately it will attack other molecules to producing a bond with them. Remember, H plus contains only 1 proton, no electron. That's why we call H plus, which is hydrogen cation, proton. Proton is H plus. Very good. Now we only need proton. H plus, it's proton. Well, we're going to work with proton right now when we put acid into water. If we put acid, if we pour some amount of acid in water, what will happen? Okay? Suppose that we have HCl. I prefer to change the color to another color because of, you know, I feel depressed with black color always. Well, we have HCl. Suppose that we put HCl into water. What will happen? Firstly, look. It's very good. Firstly, HCl, look, don't decide directly, okay, until you finish the video. Don't decide directly. I know what I'm going to write. HCl, it will produce H plus Cl into water. Okay, but because H is super active, so it will react with H2O. It can't stay freely. So immediately it will combine with water molecule to producing H3O. That's why we summarize the reaction in a single reaction like this. Look, HCl plus H2O to producing H3O plus Cl negative. And now let's deal with the hydronium ion. It's called hydronium ion. Okay. How do we get hydronium ion? Look, HCl releases its proton, which is super active. It cannot stay freely. And the thing starts with this. Let's see. Here. Okay. No. I'll escape the page totally. Okay. And now we have H, which is proton. H attacks water molecule to producing H3O. So H3O, it's proton, but hydrated. The water of hydrate, it means watering, putting water, okay? So H plus water is hydrogen ion. Hydrogen ion, again, it's active, so it will attack other water molecule to producing, look, H2 plus H3, it will be H5, O plus O, it's O2 plus. Mr. I can say still it has same behavior of its grandfather, which is proton. It's active. So again, it attacks a new water molecule to producing. Look, H5 with 2H, it will be H7. 2 oxygen with 1 oxygen, O3 positive. So this consequence will go farther, okay? And we don't know how much it will go deeper farther, okay? But you have to know that. Look, the point is that this one, all of them are proton, but hydrated. So all of them are, look, hydrated proton. That means proton plus H2O. This is hydrated proton. You know how it's easy? And now, anytime if we have some numbers of hydrogen atom with oxygen combined together with positively charged, we can say it's hydrated proton immediately. Is that true? No. For example, we have H6O4 plus. It's hydrated proton, and this one H9O4 plus. It's hydrated proton. So how to identify the hydrated proton? First of all, this process, it's exothermic. It's exothermic and related to acid solutions. When you have acid solutions, there will be hydrated proton, which is exothermic. It means the jar, the beaker, the container gets hot, okay? The temperature will rise because of producing of hydrated proton. And now, how to identify the hydrated proton? Look, I talked about all of them in a very deep detail, more than this actually. Look, formation of H3O from the solution of HCl is H3O is hydrated proton. Did you remember? Hydrated proton. Did you want to accept it if we put HCl into water? Resulted hydronium ion. Did you want to accept this? Of course, yeah. Because of its acid, if we put HCl into water, it will produce hydrated proton, hydronium ion. So it's accepted. We have two answers of accepted. Not accepted, no. Not accepted, no. And now, it's exo or indo. Of course, it's exothermic. So accepted and exothermic. It's very easy. How to identify the hydrated proton? We have to check the number of hydrogen. How to identify or how to decide that which ion is hydrated proton and which one doesn't. We have a simple rule. We can apply on any ion, then we can decide that it's hydrated proton or not. We have to check number of hydrogen, okay, we have to calculate number of hydrogen by number of oxygen in its formula times 2 plus 1. Let's see. Hydrogen, first of all, no, it's only proton. It's not hydrated proton. Water molecule, no. Hydrogen chloride, no. And this one, H3O. It has 3 hydrogens. Look, let's calculate. Hydrogen equals 2. 2 times number of oxygen. How many oxygen do you have here? 1. Look. 1 times 2. Okay? Plus 1, it equals 3. That means it must have 3 hydrogens. Yeah, it has 3 hydrogens. It's hydrated proton. It's the right answer. Another question. You will understand better with this question, so please don't be sad. Let's apply the question to you. We just solved this one. Which of the following is not the hydrated proton? We have to calculate number of hydrogens. Okay? Number of hydrogens. Hydrogen equals to 2 times oxygen. Here we have 1 oxygen. 1 times 2 and plus 2. It equals 3. Yeah, it's hydrated proton, but it says which one it doesn't. So it's not a right answer. Right? This one. Let's check number of hydrogen. Okay? Hydrogen equals to 2 times 3, or just like this. We have 3 oxygens. 3 times 2 plus 1, sorry, plus 1, okay, equals to, plus 1 equals to, 2 times 3 is 6, plus 1 is 7. Yeah, it's hydrated proton, so it's not the right answer for this one. Look, hydrogen equals to 2 times 2 plus 1 equals to 2 times 2, 4 plus 1 is 5, but it has 4 hydrogens. Yeah, it's not hydrated proton, so it's a right answer. Let's check this one. Hydrogen equals to 4 times 2 plus 1 equals to 9. Yeah, it has 9. It's hydrated proton, so it's not the right answer. So by this way, we can identify the hydrated proton. Okay? Very good. And now we have strong and weak electrolytes. Okay? How we can understand about strong and weak electrolytes? It's a very different universe from the others. Strong and weak electrolytes includes many other objects in a great deal of chemistry. Because of we will see this, we have this guest in many of the other chapters. That's why please understand about strong and weak electrolytes. Okay, let's open a new page again in order to understand about the strong and weak electrolytes. As I told you, please, it's very important. So get anything about strong and weak electrolytes. It's very useful in many of the other chapters. Okay. What is strong and weak electrolytes? What is strong or what's weak electrolytes, first of all? When we say strong or weak electrolytes, we have to think about their tendency of conducting electricity. When we say strong electrolyte, that means we have conduction of electricity so strongly. How we can have a strong conduction of electricity? When we have more iron, okay? So for the strong electrolytes, aqueous solution of strong electrolytes contains, look, contains more ions. But here, okay, it contains less ions. Why it results more iron, but weak electrolyte results less iron? Why? Because of here there's a weak attraction force. Because of there's a weak attraction force, so it breaks down so easily, results its iron in a large amount. But here, no. Because of strong attraction force, Because of the strong attraction force, so it will break down in a trace amount of molecules. That's why there will be less ions. So there will be poor electric conduction. Okay? Actually, both are electrolyte, but here we have a strong electric conduction, but here we have weaker because of small amount of ion, large amount of ion. Why small amount of ion? Because of strong attraction force, because of weak attraction force. So as much as the electrolyte become stronger, the attraction force will be weaker. It's important. And as much as the electrolyte become weaker, the attraction force becomes stronger. So there's a reverse relation between the electrolyte strength with the strength of the bond. There's a reverse relation between them. Okay? And when we write their reactions, okay, let's see. Suppose that we have HCl. Okay, please come here. I'll change your color, so don't be angry, please. Okay, look, HCl plus water. But here we have HF plus water. Okay, look. Did you remember I recommended to you many times, please memorize list of strong acids and weak acids. When I say weak electrolyte, it means weak acid and weak bases. When I say strong electrolyte, it means strong acid and strong bases. Okay, we have HCl, strong acid, so it's a strong electrolyte. Okay, when we write the reaction of strong electrolyte, we have to write the direct arrow or the direct arrow, okay, to producing its ions, which are H3O and Cl and N. Look, there will be more ions, so here we have more concentration. More concentration. So, because of the attraction force here, it's very weak attraction force, so it will break completely. It will disappear, so it will be zero. All of the amount of HCl convert to ionic form. That's why we have more ions here. But here the concentration of the molecule of the electrolyte is zero. So, what we have in aqueous solution of strong electrolyte, what we have? In aqueous solution of strong electrolyte, that means if we put strong electrolyte into water, what do we get? Or count the particle types in this aqueous solution if we dissolve strong electrolyte. First of all, the molecule of strong electrolyte disappear. So there will be zero amount of molecule. Only cation and anion in a large quantity. But about weak electrolyte. For weak electrolyte, we have strong attraction force between H and F. But here the attraction force, it was very weak. So here is strong. Look, it's weak acid. It's weak electrolyte. So it's weak electrolyte. Surely, that means the bond is strong. Because of the bond is strong, so it's very hard to break. So there will be less amount of ion. Less ion. And we have to use reverse arrow. Reverse arrow, please. And write the ions. H3O plus F negative. The difference is this. Let's see. Here. Okay, this is good. Look. Here is a strong electrolyte. It will be disappeared. All the amount of a molecule will be convert to ionic form. So here, maximum concentration is the ions. But for weak electrolyte, because of the strong attraction force, only a trace amount. Suppose that we just dissolve this amount of HF. Only a very small amount will undergo through this reaction. The rest will be HF molecule. So here we have less cons. That's why there will be poor electric conduction. And here we have maximum cons. But here the molecule disappeared. Here maximum cons. Because of the attraction force is very strong. So it won't go through ionization except of a very trace amount, which is this part. Look, this part will go through ionization and the rest will be HF molecule. That's why in aqueous solution of strong electrolyte, we have a large amount of the ion, but of weak electrolyte, we have a small amount of the ion. And about the molecule, zero amount, but here, maximum cons of the molecule. That's why we can say that strong electrolyte contains only cation and anion. Weak electrolyte contains cation, anion, and a molecule. Cation, anion, less cons, molecule, maximum cons in a weak electrolyte solution. But for strong electrolyte, there will be no molecule, only cation and anion. And let's go through some questions. Okay, I explained all of them. Okay, here. Which of the following can be produced when we dissolve HCl in water? We knew that. H3O and Cl, okay? The last thing is the difference between words of concentrated, diluted, strong, and weak. Okay? Word of concentrated, diluted, strong, and weak. I'll explain here. Let's see. تماشا كبابي من. Concentrated. And diluted. Okay? Strong and weak. What is the difference between them? These are four different expressions. Concentrated. It means it's related to concentrated and diluted. They related to amount of solute. Okay? Concentrated, it means more amount. But diluted, it means less amount. Okay? It's very easy. Concentrated and diluted, they're related to the amount of solute. As much as the amount gets higher, it will be more concentrated. As much as the amount gets smaller, it will be diluted. But strong and weak, they're related to degree of the ionization. Degree of ionization. If the compound ionizes highly, it will be strong. If it ionizes very less, it will be weak. Okay? High ionizable compound. But here, less ionizable compound. Okay? Well, let's go through some examples. Okay? Very good. Okay, doesn't need. Let's go through this example. A solution of 15 molar of acetic acid. 15 molar is a very big number. It means high amount. High amount, so it's concentrated. So firstly, it's concentrated. It's concentrated. We have two answers of concentrated. So forget about diluted. Okay? And acetic acid. Acetic acid is CH3COOH. So it's weak electrolyte. So it's concentrated and weak electrolyte. The right answer is concentrated and weak electrolyte. What if we have 10 molar HCl? Okay, it's high amount, so it's concentrated and it's strong electrolyte. So there is no relation between strong, weak with concentrated, diluted. Okay? بەم شێوەیە کۆتاییمان بە section 1 لە بەندی یەکەم هینا ئینشاءالله لەوانەی داهاتوو دەست دەکەین بە colligative properties کە section 2 هەوڵدن محاولە بکەن ئەو بابەتەی جوان تێبگەن ئەگەر دەتانەوێت لە کەرتی دووەمیش بە هەمان شێوە بە مەزبوطی لەگەڵ بابەتەکەی بەردەوام بن تاوانێ داهاتوو بەخواتان دەسپێرم خواتانە